Good morning, good afternoon, good evening. Thank you for joining us for the Software Effectiveness Conference. I'm Steve McConnell, author of Code Complete and CEO of Construx Software. Thank you for joining us here today. I would like to talk this morning about secrets of the Agile scaling gurus. This is, I think, a very interesting topic and one that hopefully you'll agree is interesting. So I thought I'd start by talking about my company, Construx's first experience with scaling way back when I started the company quite a few years ago. Basically, going back to 1996, quite a while ago, we had a client that had been a startup company, literally two guys in a garage, that had grown to a technical staff of about 50. And the rest of the story is a little bit cliched in my experience. The project had grown, the company had grown, people weren't getting as much work done as they used to. They were having all kinds of quality issues they hadn't experienced early on. And the whole thing ended up being a little bit of a cliche, I think, when you look at it from the point of view of scaling. But we'll get into some details about why that really is over the course of the talk. So I want to make clear before we get too far into the subject what I mean by Agile scaling. And I think a lot of times when people talk about Agile scaling, what they're talking about really is taking Agile practices and propagating those across individual teams. And I don't refer to that as Agile scaling. I would refer to that as Agile adoption. It's an interesting topic. It doesn't happen to be the topic, though, that I'm going to talk about today. What I'm really talking about here is conducting a single large project using Agile practices. And I think the decisive factor here is having all teams contributing to a single code line. That really is the focus of this talk. We get all kinds of issues that come up when we get multiple teams contributing to the same code line that we don't have when we have a bunch of independent projects that happen to be part of a larger organization. Also, in larger organizations, a lot of times we'll have more of a federated solution where we do have standalone, small Agile projects, but we also have Agile projects that are larger that have contributions from multiple teams. So we also are talking about those kinds of organizations as well. Not the standalone small Agile projects in those organizations, but the larger projects that consist of multiple teams. So let's then talk about tools for understanding scaling. And here I think I'm going to bring forth three tools in this talk. I want to bring forth the 4 factors lifecycle model, which is the subject of my lecture series in the Construx On-Demand library. And in that 4 factors lifecycle model, one of the 4 factors is size. And so we'll focus on that factor today. I want to talk a little bit about Kokomo 2, an estimation model that I don't think is all that useful for estimation purposes, but I think it's tremendously useful for understanding the ins and outs of software project dynamics. And so we'll dive into that a little bit. And then I want to come back to a topic that is I've been using for quite a few years now called the intellectual phase profiles model and talk about how that is affected by project size and how we can use that to understand how we can scale our Agile projects. So let's start then with tool number 1, that 4 factors lifecycle model. This is described in my Understanding Software Projects lecture series, and that's something that we will send you a link to at the end of the conference. In that 4 factors lifecycle models, the 4 factors are size, human variation, defects, and uncertainty. And in the center of that, we actually have the lifecycle model. The factor that I want to focus on right now is that factor of size, and that does have some interactions with the other 3 factors. So there are interactions between size and human variation, size and defects, and size and uncertainty. And so I think that understanding the ins and outs of software size really is important to understanding software project dynamics, period. It certainly is also key to understanding some of the issues that come up with Agile scaling practices, and so really how to perform development work at scale. Key point number 1 in this area, the guru secret. I've got various points illustrated in this talk as guru secrets. The first guru secret is just that large projects are difficult. And you might think this is obvious, but I think we really can't go without saying that there's a reason we're talking about scaling and people are interested in the topic of scaling, which is that people have experienced the idea that large projects are harder than small projects. And that's, I think, worth dwelling on. If we look at project outcomes by project size, and it looks like I've got a little bit of an error in how my slide is rendering here, but if you really focus hard on this slide, you can see the colors. What this shows is that at very small project sizes, success is basically guaranteed, but as we get into projects of any size whatsoever, the percentage of projects that are late increases, and I don't know if you can quite make that out, but that's the yellowish part of the figure, and the percentage of projects that fail outright, that are canceled, and that's the reddish part of the figure. It looks black on the screen really, increases. And so when we get out to the very largest size projects, we've got more than half of projects failing. That is just being canceled before they deliver any working functionality to end users at all. And so interestingly enough, as the projects get larger, the risk of late delivery becomes higher and the risk of outright cancellation becomes higher. And when we get out to the very largest size projects, our primary concern should be finishing at all, because we have more than half the projects failing outright at that very largest project size. So why are large projects difficult? Well, I think they're difficult for all kinds of reasons, and a brief list of highlights, by no means the full list, would be that we've got to prioritize hundreds of requirements. It's not just collecting them and analyzing them, it's also prioritizing them, putting them into a backlog and prioritizing those. We've got to track dependencies, not just for one team, but across multiple teams. We have to coordinate deliverables across teams. We have a larger set of stakeholders that we have to satisfy on a larger project, and we have to reconcile interests of those larger stakeholders and potentially work with political issues among those larger set of stakeholders. We need to share progress or status with the business, and to do that not just for one project, but across each individual project, plus the collection of projects considered as a whole. And then, of course, we need to make the best use of our resources and specializations, and all of these issues become larger issues as we get into larger projects. Guru secret, the next guru secret is avoid scaling if possible. In other words, if we can avoid this end of the curve where we've got a really high chance of failure and late delivery, that would be a great thing to do. If we can stay on the left side of this curve where delivery is much more likely, on-time delivery or delivery at all is much more likely, then that's really a good thing. Also, by keeping projects small, we're going to lower our error rate. As project size increases, error rate increases. And that's not just the total number of errors that increases. That is the rate at which errors are introduced into the software increases. And the larger the project gets, the higher the error rate becomes. And so not only does the absolute number of errors increase, but the proportion of errors actually increases disproportionately as size increases. So that's another reason to try to keep projects small if possible. Productivity decreases as project size increases, and in larger project sizes it decreases quite dramatically. As I mentioned at the beginning, this startup company that my company worked with 20 plus years ago, the founder of that company was pretty frustrated that his 50-person team was nowhere near as fast as he and his partner had been when they were working in their garage a few years earlier. This is actually expected. As project size increases, per person productivity decreases, and that's a dynamic that we're going to try to reduce that dynamic or minimize that dynamic as much as we can, but it's a dynamic that we should expect. Per person productivity is going to decrease as project size increases, in part because of that increased error rate, in part because of increased coordination issues, and all those other factors that I listed a few minutes ago about what makes large projects difficult. So, there's also the question of whether scaling even works. And Larry Putnam, who's one of the gurus in the software estimation world, has some really interesting data that suggests that as we increase team size, we don't always get more output. His data suggests that, and I again apologize, I think this slide's not getting rendered very well, so I'm going to just have to talk through it. But what his data says is that when we have business systems that are all about the same size, in his study, he had about 500 systems, and there were about 100 each in each size category, and all of them were at about 100,000 lines of code for the delivered system. At the very smallest team size of 1.5 to 3 people, the green dot you can see is the schedule dot, the red dot is the effort dot, and those are at a certain level. As you increase team size, to 3 to 5 people, the effort goes up and the schedule goes down slightly. As you increase team size to 5 to 7 people, effort goes up again and schedule goes down, but only slightly. The interesting thing about Putnam's data, and I'm sorry that you can't see this, but we'll get corrected slides available later so that you can take a look at those if you're interested. As you increase team size to 9 to 11, bearing in mind that we're holding project size constant at 100,000 lines of code, and it's a particular kind of project, a business systems project, when you go to 9 to 11, effort goes up a lot, but schedule also increases. You actually are putting more effort in and getting a longer project, not a shorter project. And as you increase to 15 to 20 people, effort goes up tremendously and schedule goes actually stays about constant, if I'm remembering the graph correctly. But it's about the same as it was at 9 to 11 people, but it's much higher than it was at 5 to 7 people. So the point here is that there is clearly a point of diminishing returns in adding people to a project. And we should be thinking about, as we're thinking about a large project, are we actually gaining anything by making that team larger? Or is it possible that we're actually losing ground as we increase team size? Putnam's data says that for certain kinds of parameters, we're actually losing ground as we increase team size. So the next point I'd like to dwell on for a moment is, I think the perception, I think we talk about Agile scaling as though in some way scaling Agile projects is more difficult than scaling projects was for sequential or waterfall projects. I think this is incorrect. Agile development does not make scaling more difficult. What we find is that in the old days, pre-Agile, pre-Scrum in particular, I think, even small projects were problematic. And because organizations adopted Scrum and adopted Agile and became more successful with these smaller projects, they start to think, well, gee, now that small projects are going pretty well, maybe we want to take those practices that are working on small projects and somehow extend those to our larger projects, so our larger projects work just as well as our smaller projects. But this does not say that Agile has somehow made large projects more difficult. What it says is it's dialed up the contrast between easier small projects and large projects, which are difficult regardless of whether we're doing Agile approaches or sequential approaches. And I think the fact that Agile practices, Scrum in particular, actually in my mind have made success on small projects more reliable, more repeatable, in some sense easier. That actually makes it easier to scale up a large project when we can depend on the smaller projects that make up the large project being successful, which we couldn't even depend on in the old days when we were doing everything in a waterfall mode. So I think the corollary of this is that if we can perform well in the small, that supports, it doesn't guarantee, but it supports performing well in the large. And the other corollary is that if we're doing poorly in the small, that's going to undermine doing poorly on large projects. And so if we're having trouble, if we're struggling with our small projects, we really shouldn't even be thinking about taking on large projects, because if we can't successfully conclude a small project, the odds that we're going to be able to successfully conclude a large project are really, really low. The next guru's secret for Agile scaling is to, based on Polya's book, How to Solve It, which is find a problem more general than your problem. And I like this as a guideline for a problem-solving approach. I think that the problem of scaling of software size actually is a more general problem that applies across more dimensions than just Agile versus non-Agile. We see this scaling issue come up in a lot of different ways. For example, if we see a company whose software does well, that software will grow over time. It's just the nature of the beast. If the company does well and people like its software, the company will add to its software as time goes by. The software will become bigger, the team will become bigger, and those large projects will tend to struggle more than the smaller project did in the early days of the company. Another corollary is in pilot projects. Pilot projects tend to be small. The whole nature of a pilot project is normally that we're trying something in the small before we try it in the large. If that small pilot is successful, then we tend to roll it out. And the definition of rolling it out is expanding it, making it larger. And those larger scale rollouts are often problematic. And sometimes the reason they're problematic has nothing to do with the factor that's being piloted. It has to do with the scale, the fact that we're rolling it out to a larger scale, and it's the larger scale that's problematic, maybe more problematic than the thing that's being piloted. New technology. I think we tend to see, pardon me, projects in new technology. Excuse me. We tend to see projects in new technologies start small. If they're successful, the companies naturally want to try larger projects with those new technologies, and those larger projects often become problematic. And interestingly enough, even though the larger projects that are occurring at a time after the technology has started maturing, you would naturally expect that the initial projects, when the technology is least mature, would be most problematic. And then as projects are conducted at a later time, as the technology matures, those would be less problematic. What we see is that they tend to be more problematic, and it's not because the technology is less mature or is static. The technology is in fact more mature and easier to use. The problems come from the fact that we're now trying to do that work with larger projects, and people often misdiagnose the source of problems as being from the technology, but a lot of times the problems are really from scale, from the fact that we're trying to scale up. And we've seen this cycle over and over again in the software world. We saw it years ago with client server systems. We saw it with the move into internet development. We've seen it more recently with mobile development. We've just seen the same pattern repeated again and again in the software world. Methodologies, and I think this is the last one I've got in this segment, but I think by now you've probably got the point that if we try a new methodology in the small and it does well in small projects, we want to scale it up and use it on large projects. At that point, the challenges increase, at least in part because we're trying to do it on large projects. And that really leads us to where Agile is today, which is we've tried new methodologies in the small. Companies have had a lot of success with Scrum in particular, and so naturally want to scale that up. And so we get approaches like SAFe or DAD or LESS or Nexus and so on that are all attempts to take these successes in the small and try to have similar levels of success in the large. So the next guru's secret is that a key challenge of software scaling is the non-linearity of software project challenges. And we kind of tend to assume that as the project scales up, the challenges will scale up proportionally, and they really don't. Some attributes scale linearly, but some attributes scale non-linearly, meaning the challenges scale up faster than the size of the project scales up, and so we have a disproportionately larger challenges as the project size increases. To put this in Agile terms, we sometimes in Agile, this has been deprecated recently, but the chicken and pig example is if we have an X times Y problem where we say our project is 10 times as large, that doesn't just give us chickens and pigs that are 10 times as large. At that size, they actually start to look like different animals, and that's the same thing in software. As the software size increases, the challenges start to look like different animals. We can't just multiply everything by X and assume that that's the same size challenge. So, we see these new challenges emerge at larger scales. As a company's software grows over time, there are new challenges that emerge at larger scale. As we roll out the pilot project, we have different kinds of customers with the company growing. We have different kinds of people using the techniques in our pilot. As we get new technology, we get additional issues that the technology needs to address at larger project size. And with Agile projects, we have basically interactions and practices that simply aren't contemplated in the practices that are intended for use in the small. And so we have to add in practices that do address issues of scale that simply don't exist at the individual team level. And so these really just are not bigger lifts of the same things. They are different lifts. We're still lifting a lot of the same stuff, but we also have to lift some different things as well. So I think one of the things that we need to understand and take to heart is that if elements of the problem are scaling non-linearly, then elements of the solution need to scale non-linearly too. And that has implications for how we go about planning projects, how we go about thinking about requirements, how we go about staffing the projects, what the roles are on the projects, how many people and what proportion of people are in each role, and so on and so on. And so if we understand that problems scale non-linearly, then we can really start to understand that the solution needs to scale non-linearly as well. The next guru's secret is this fundamental nonlinear concept that software has this idea of a diseconomy of scale. And I think I have significantly hinted at this already. But the idea is that in a lot of the universe, as we build like a bigger manufacturing plant that produces more units, we get what's known as an economy of scale. That is, the bigger the manufacturing plant gets, the lower the per unit cost becomes. And in software, we don't get that. In software, we don't get unit cost decreasing as production increases. In software, the larger the project gets, the higher the per unit cost becomes. In this case, the per unit cost would be line of code. What that means is that per person productivity declines as project size increases, and this is known as the diseconomy of scale in software. Diseconomy of scale is not a super dramatic effect in software. It's not a big, exponential curve as shown in the graph on the left. It's a very mildly exponential curve as shown in the graph on the right. But it is a factor that we have to consider as we scale up outside of a pretty narrow size range. And so, if we have projects that vary by, a factor of 2 or maybe a factor of 3, we probably can treat those as fairly linear relationships. So if I have a 10-person project that's twice as big as a 5-person project, I'm not going to run into too much difficulty if I assume a linear increase. But if I've got a 25-person project that I'm trying to plan as 5 times the size of a 5-person project, then I'm going to run into trouble because I've got some diseconomy of scale coming into play based on that significant difference in project size. Now, diseconomy of scale, I think sometimes in software engineering literature, software estimation literature is presented as though it's a continuous curve. The graphs that I just showed you made it look like it's a continuous curve. I think in practice, it's actually more of a step function. There are certain points at which diseconomy of scale increases drastically, and then other points where it's hardly increasing at all. And I think the diseconomy is primarily about coordination overhead, and coordination can take a lot of different forms. It can be management coordination, requirements coordination, architecture coordination, or process coordination, and then higher defect correction effort, disproportionately higher defect correction effort because of all the above factors. And so I think what we end up with is this idea that diseconomy of scale is a step function, and the steps really occur at the points where additional levels of coordination are needed. And basically, I see that as being a powers of 7 kind of a function, where if we have a team up to about 7, we can have 1 leader, 1 scrum master. Team can be pretty self-managed. When we get up to about 50, the power of 7 would be 49. We're going to need multiple leads, multiple scrum masters. We're going to need test specialists. We're going to need a group manager. We probably need at least 1 architect, which we didn't necessarily need at a team size of 7. We might need a director level manager. So we've actually increased the number of different specializations that we need at that size. And as we go beyond that power of 7 up to the 250 to 350 range, then we're going to need leads and scrum masters and test specialists, but we're also going to need group managers, dev managers, test managers. We're going to need not just architects, but probably a chief architect. We'll need director and maybe a VP as well. So we have some additional roles that come into play. And it's those overhead roles that I think account for the diseconomy of scale in the step function. And so I see that as looking like this. And I think it's important to remember that we're not just talking about increased coordination. We're talking about additional kinds of coordination work that come into play on larger projects. So my diseconomy of scale looks like this, where if you look at the yellow line, that represents the per person output, or rather the total output. Let's start with the red line. The red line represents essentially average per person output, and you can see the points where the white arrows are pointing. The per person output drops, and that's approximately at those powers of 7 levels. And so total output is shown by the yellow line. And as you can see, as we add people at the left side and small team sizes, total output increases pretty quickly. But as we get further over to the right, total output increases much more slowly, and that's really because that per person productivity is declining. And then there are points you can see where the yellow line actually drops, meaning we add people and total output actually goes down. And this is suggestive of the idea that there are certain project sizes that we probably just shouldn't try to do at all, because the coordination overhead required at those sizes actually exceeds the increase in productivity from the additional person or persons that we add. So I think that's a pretty interesting perspective on diseconomy of scale. So, and I think I talked through this slide already, so this is really just for your reference. So, how does this all apply to Agile scaling? I think problem number 1 is that planning large projects as though the diseconomy of scale does not apply is a systemic problem in software. We have to take into consideration the idea that we have different planning considerations at large size than we have at small sizes. And problem number two is not accounting for the step function, meaning that there are certain sizes we should be very nervous about and maybe either stay well below or stay well above, but not try to operate a project right at that power of 7 level. All right, the next guru's secret is that the holy grail here, if we can do it, is to conduct a large project as a series of small projects. And this has been the holy grail for maybe 40 years in software. All these comments I've made about keep projects small, the diseconomy of scale, and so on, all of these imply the idea that, well, gee, if we could take our large project and break it up and run it as a series of small projects, then we get all the benefits of small projects and we wouldn't have to worry about large projects and diseconomy of scale and so on. And that's really true. That is the holy grail. If we can conduct a large project as a series of small projects, that really is kind of a large project perfection. The question here is, can we partition the work in a way that actually allows us to run a large project as a parallel series of small projects? And this suggestion goes back to the Mythical Man Month in 1975 at least. The challenge here is that the structure of a system reflects the structure of the organization that built it, known as Conway's Law. And so for that parallel series of small projects to work, the work has to be truly partitioned. That is to say, there cannot be interactions at the technical level. There cannot be architectural connections between the different pieces of work, because if there are, then per Conway's Law, not only are we going to have architectural connections between the different pieces of the software, we're going to have human connections between the different pieces of the software teams. And now we don't have truly independent partitioned small projects. We've got an interconnected set of small projects, i.e. we actually have a large project. And so, the holy grail here is worth thinking about, but it's also very difficult to actually attain. And so I think what we need to do here is, it's not a black and white proposition where it's fully partitioned or it's completely all jumbled together. There's definitely a scale here where if we can partition the work more rather than less, we can divide the teams more rather than less, we can reduce the communication dependencies, and we can at least approach the idea of running a large project as maybe a smaller project, maybe not completely as a series of small projects, but a smaller project. And if we can actually pull that off, then we can have a more efficient large project. But what this requires is a focus on software architecture up front so that we actually design the system in a way that supports the human interactions on the system. And that is considered, unfortunately, by many to be an unnatural fit with Agile projects. And I think this is an area where if we want to have large projects, we actually have to make some accommodations to the ethos that goes along with small Agile projects, where with a small Agile project, we might be able to treat everything as emergent design and be successful with that. With a large Agile project, we have other considerations that we have to bring to mind, including how are we going to organize the large team that conducts that large Agile project. And in order to organize that, having some software architecture that supports the human organization architecture turns out to be really, really helpful. And that's something that we actually benefit from putting some thought into up front. Doesn't mean we have to design every aspect of the system in detail up front. It absolutely does not mean that. What it does mean is we need to do enough thinking about the architecture that we make sure that we streamline the human organization by virtue of having streamlined the technical organization. I've dwelled a little bit on the idea that culturally this might be difficult to accept in an Agile context, but it's important that we do that if we want to be successful in large projects. Let's also not forget about the fact that this is just difficult in general. Cultural issues aside, getting a good architecture on a large system is a non-trivial activity. It's challenging to get good architecture. And so this is something that we actually have to put some effort into to pull off. And a lot of times we're only thinking about the technical architecture and the implications technically of the architecture. So now I'm saying for the large project to really work well, not only do we still have to consider all of that, but we have to consider the impact on the human organization at the same time. And so that makes architecture maybe even more important than it's been historically, and more critical to the success of trying to scale up Agile practices effectively. So to summarize just the general aspects of size, large projects are difficult, and we just need to take that into account when we talk about scaling Agile. This is not primarily a problem related to scaling Agile. It's primarily a problem related to scaling, period. And Agile happens to be not immune to all of these problems related to scaling. If we can avoid scaling, we should. Agile practices probably make that easier rather than more difficult, to the degree that they contribute to success on small projects rather than large projects. I think they help rather than hurt. And solving the general problem of how we conduct a large project certainly will help us solve the more specific problem of how we conduct a large Agile project. Key point to keep in mind here is that software project challenges scale non-linearly, and so our solution also needs to scale non-linearly. And if we can run our large project as a partitioned series of small projects, that really is the holy grail, but that's difficult to pull off. So with that as a prologue, and bearing in mind that the main point, the most important point here, is that software project challenges scale non-linearly, let's go ahead and turn to the second tool in this talk, which is Kokomo 2. And I think what I've subtitled this part of the talk is "What got you here won't get you there." And what that means is what's led you to be successful on small projects is not really the same set of factors that's going to lead you to be successful on large projects. If you've heard me talk before, I talk about Kokomo 2 a lot. And I don't find it that useful as an estimation model, even though that's its intended purpose. It's not due really to any weakness of the Kokomo 2 model. It's more due to weakness of how the model actually gets applied by fallible human beings in practice. So I think there's some usage failure associated with the model for estimation purposes. But having said that, I think that the analytic work that has gone into isolating the impact of different factors on software project outcomes, the statistical work that's been done along with Kokomo 2 is probably the most rigorous statistical work that's been done in the software industry in terms of truly isolating the impacts of each individual factor one at a time. And so I think it's a tremendously interesting and useful model to look at to gain insight into the degree to which different factors affect software project outcomes. And if you look at the diagram that's shown on the slide, the yellow factors on the diagram are factors that the Kokomo model has found affect projects linearly. So as I've been describing throughout the talk, these are factors that have the same percentage effect at a small project size as they do at a large project size. The factors that are shown in red or orange, depending on how that color shows up on your screen, the factors that are shown as red or orange are known as scaling factors in the Kokomo model. And those are factors that have been found to affect software project outcomes non-linearly. These factors affect projects more the larger the project gets. And so the graph here is shown from the point of view of a relatively small project. And you can see the text might be a little difficult to make out, but the factors of precedentedness, process maturity, architecture and risk resolution, development flexibility, and team cohesion are the 5 scaling factors. And those are really all in the bottom half in terms of influence on project outcomes at small project size. And these factors are arranged from largest influence at the top to smallest influence at the bottom. But if I redraw this graph from the point of view of a large project rather than a small project, the graph looks like this. And now we see that those 5 factors shown with the orange or red bars are now all in the top half in terms of influence in software project outcomes. And so what this says is that if you start out in a small company with a small code base and a small project, and you're not thinking too much about precedentedness or your process maturity or your architecture or your approach to risk or your team cohesion, it's probably not a big deal. None of those factors in the top half for small projects. But as your project grows, you get more people on the team, you get a larger code base. If you're not starting to pay attention to these factors, you're really going to suffer, because as you get into larger projects, now these factors are in the top half in terms of their influence on software project outcomes. So, and the challenging thing here is that typically, we don't wave a magic wand and instantly have a large code base. Large code bases are created over time. And so large code base and old code base really are extremely highly correlated. And we don't grow to a code base of 5 million lines of code in a year. It takes years to get there. And guess what? If it takes years to get there, a lot of that code base will be old by the time we get to that large size. So, small code base and young code base are highly correlated. Large code base and old code base are highly correlated. And the only reason we grow to a large code base is because we have created something useful and a lot of people are depending on it. And that actually means a lot of these Kokomo factors, not only do they have more of an influence at higher sizes, but the value they have is worse. That is more challenging. So for example, in particular, development flexibility is an oddly named term, but what that refers to is the flexibility you have in interpreting requirements a little bit flexibly. And if we have the best performance on this factor, what it means is we have some latitude to make slight shifts in how the requirement is interpreted. If one interpretation is going to dramatically increase cost, but we can have a different interpretation that has a lower cost, we're free to do that. Whereas the more adverse impact on the level of effort in the project says we have very rigid requirements where even if we could slightly change the interpretation and dramatically reduce the effort, we're not allowed to do that. And so we have to implement that requirement very rigidly in the exact way it's defined. That tends to be a bigger factor on older code bases because we have an established user base. We have maybe other systems that are interacting with our system and depend on it acting and in an exact way. And so really as systems get older and larger, the requirements also tend to become more rigid. And so this scaling factor tends to affect projects worse as project size increases. It's not necessarily true for the other projects. Like precedentedness is an interesting factor. That refers to how precedented or unprecedented is the work that we're taking on. And what that factor says, because it's a scaling factor, is that if we try to do a small project, and I think I'm actually getting ahead of myself here, so let me jump ahead to the slides that actually talk about this, is that I think a lot of times organizations ignore the idea that the challenges scale non-linearly. And so when organizations start to struggle on larger projects, a natural response, but one that's pretty ineffective, is to try to repeat the practices that made them successful on small projects, but they repeat them harder with more commitment or with more fidelity on large projects. And that's natural, but it's just not very effective because the challenges that are not arising probably because people aren't working hard enough or not committed enough or not using the practices with high fidelity. They're arising because those practices that work at small size are not adequate on their own to solve all the problems that you need to solve at large size. In other words, it gets back to the subtitle of this section, which is what got you here won't get you there. So let's talk about each of those 5 scaling factors just for a minute. I got ahead of myself a little bit here, so we've already talked about some of these to some degree. Precedentedness, we talked about this. It's the third most important factor on large projects. And I think the bottom line here, which I didn't mention before, really is that companies struggle when they try to take on projects that are too large in an unprecedented area. And so, there's this old saying, don't try to advance the state of the art in more than 2 dimensions at once. And I think if you're trying to do a project that's larger than you usually take on and in a more unprecedented area than you usually take on, that's just a very, very challenging combination to be successful with. And it's an example of how size and uncertainty interact in my 4 factors life cycle model. For architecture and risk resolution, this really refers to the number and severity of the risks that have been identified and the extent of activities that are focused on risk management and architecture work. It also requires having staff available to support architecture work, which you don't necessarily even need for smaller projects. And so I think what we see is that small projects can really succeed by the seat of the pants in these areas, but large projects need more explicit focus on the activities, and they need a more explicit focus on having qualified staff to actually do the work as the projects get larger for those projects to be successful. And here I think the interaction with Conway's law is interesting, that sometimes, I talked about it earlier as though the software architecture drives or should drive the human architecture. Sometimes the architecture of the human organization needs to be considered in driving the software organization. So if we have a requirement to have a geographically distributed team, which is very common these days, or if we have an organizational structure that arises through acquisition, which is also very common these days, that can actually have implications for the software architecture. And if we're designing a software architecture that's oblivious to the fact that the team is operating across 5 different sites, or that there are different legacy sites that exist because of acquisition, we're going to suffer because our technical architecture does not account for the human organization. And so we need to be sure we're accounting for that. So the bottom line on architecture and risk resolution is that we see companies struggling with projects that are too large for the architecture and risk profiles of projects of that size. We can take on a really challenging architecture project in the small and be successful with that. If we try to take on a really challenging architecture project in the large, we're going to have a much lower chance of being successful with that large challenging project. The next factor I talked about really already, the requirements flexibility factor. And I don't know that I need to repeat myself too much here, but I will just reiterate that greenfield projects version 1 tend to have a lot of latitude in interpreting their requirements, whereas later systems, legacy systems, tend to have less latitude, and they tend to be larger. So we really kind of suffer in 2 directions at once on this particular factor. Team cohesion is another of the scaling factors, and this really refers to interactions within the team broadly considered. So that includes not just the technical team or the development team, but also includes stakeholders and stakeholder groups. And the elements here include how consistent are the stakeholder objectives. Fairly obviously, if we have more stakeholders because we have a larger project, there's more of a chance for stakeholders to have competing objectives. It refers to stakeholders' willingness to accommodate each other's objectives. The larger the group becomes and the more diverse the stakeholder group becomes, the more potential we have for people to dig in their heels and maybe not be willing to accommodate each other's objectives. It also includes the experience of the stakeholders working collectively as a team and explicit work to develop shared vision and commitment. So this is not just about the technical team. As the project size increases, the consideration of who's actually in the team that counts as team cohesion changes somewhat. And we've got to consider all of that as the project size increases. So, what this really means is that for small projects, we've all been on small projects with some fractious interactions and know how many problems that can create. But for large projects, we can have, a couple of dysfunctional relationships. And if those are dysfunctional between even a small number of key stakeholders, there can be some significant ripple effects that end up affecting the whole project. So this is an area where I think we just need to be ready to do some really explicit work to develop that shared vision, sense of cooperation, and making sure we're all pointed in the same direction and want the same thing in support of being successful on that larger project. Process maturity is, I believe, the last scaling factor that we're going to talk about. What this refers to is how well-defined, repeatable, and optimized your software processes are. Again, this is a factor that doesn't really matter much on small projects. You can be pretty successful with a seat-of-the-pants approach on small projects. On large projects, it becomes the 4th most important factor, so it actually ends up becoming a big deal. This is a difficult transition for companies because if you've been in an entrepreneurial state and you're maturing into a not entrepreneurial anymore, you got to sit at the grown-ups table. This can feel pretty unnatural for companies that have been successful, maybe in part because they have been seat of the pants and have been operating quite informally up to that point. And so it ends up becoming one of the more difficult transitions we see for companies and teams to make as they grow, because this very much is a case of what got you here won't get you there, and what caused you to be successful and get to this level is going to actually start to become an impediment in getting to the next level. And so what we see is a lot of times that organizations struggle and actually have to go through a painful process to make that transition and adopt the practices that are required to become successful at the larger size that they've gotten to. SAFE is interesting here, the Scaled Agile framework. I think SAFE is often characterized as not really agile because of the degree of structure. It really does have a high degree of structure. But I think at the size that SAFE really applies, which is nominally around 300 staff and more, that amount of structure is actually appropriate. It's very much the case at that size. We have to have an amount of defined structure. Now, I have some pluses and minuses about how SAFE specifically defines the structure at that size. But the idea that we can have a 300-person project without an amount of structure that's kind of sort of comparable to the structure of SAFE is probably not realistic. We're going to need to have a significant amount of structure to support the project that being successful at that size. All right, so let's take a look overall at the implications of the COCOMO scaling factors. We've seen that error rates go up as project size increase. We've seen that productivity goes down as project size increases. And I think the summary of COCOMO is that all the things that are difficult on small projects remain difficult on large projects. Those difficulties don't just go away somehow. They're all still there. So, you know, the complexity that we run into, the interpretations of requirements, staff who maybe aren't quite pulling their weight, all those issues still exist on large projects. And even if they only grow linearly, those difficulties will be at least as problematic on large projects as they are on small projects. But in addition, we have additional factors that do emerge and present difficulties at scale that aren't really a consideration at small scale, and we have to deal with those issues too. And so we see that organizations and project teams are often surprised by these nonlinear factors that emerge at larger project sizes, but it is really critical that organizations learn how to identify and deal with these factors as they try to be successful with larger projects, whether they're larger Agile projects or larger projects of any kind. Tool number 3, and this is fairly brief, is the activities and intellectual phases profile model. And we've seen that challenges scale non-linearly, and I've said that the responses or the solutions need to scale non-linearly too. The intellectual phases model talks about the fact that if we can look at the different categories of activities, it gives us a way to look at, well, which activities do we need to scale proportionately, which activities do we need to scale disproportionately, and to what degree do we need to scale the different activities disproportionately. So if we look in generic terms at activities of requirements, architecture, construction, system test, and we need to scale up the project, you know, what do we need to scale at different size? You know, do I need to scale the product owner role for requirements? Do I scale that linearly or non-linearly? What about the Scrum Master role, which is really the process? What about the architect role? So that's the design. Are there other roles that I need to scale? Other roles that I need to add that I don't even have at small project sizes? And the answer is there's no general answer to this. It depends on the nature of your project. And so if we look at a general pattern of project activities by project size, what we can see here on this graph of the activity mix, where small is on the left and large is on the right, is that activities like system test increase as project size increases. Requirements need to increase as project size increase. Architecture activity needs to increase. Construction, coding, unit test, integration test, that actually decreases proportionally compared to the other activities as project size increases. So to the degree that there's a generic answer, that's the generic answer, but there are some specifics that matter here a lot. And the specifics are, so the generic answer kind of looks a little bit like this. You know, as we scale up our project, do we need to add a lot of requirements, you know, double or triple architecture, maybe just add a little bit to construction or system test, you know, or is it the opposite? Maybe we need to add a lot to construction and a lot to system test. Well, I think a good tool for understanding this is what I refer to as the intellectual phase model. And what this says is that if we have on the horizontal axis, we've got schedule. On the vertical axis, we've got focus. And focus is a deliberately vague term. It's not really intended to be effort. It's not really intended to be cost. It really is just kind of to what degree do the challenges come from this area, and how do we need to change our focus as the project goes on. Early in the project, our focus tends to be on discovery. Yes, we can be doing some design. Yes, we can be doing some construction. Maybe we're doing a lot. But really, we're trying to populate the product backlog and get some idea of what we're doing. And the other stuff is not really the main focus. As we move into the project, our focus changes to invention or design. That is coming up with a solution to the requirements that we discovered during discovery. And then later in the project, we shift to more of a focus on construction. We've kind of got a pretty good feel for what the requirements are. The new requirements aren't surprising us. The elaborations aren't surprising us too much. We've kind of gone through the design discussions. We're not really having to invent anything new and big. We're just mostly carrying out the implications of earlier design conversations. Yeah, there's new stuff that's coming up, but not to the degree that it was earlier on. And so Well, work generally flows in a left to right pattern, whether our project is more waterfall or more agile. But I think this gives us a very useful tool for looking at where are the challenges in our project likely to come from. If we think the projects are likely to come from that upper left diagram, say a bigger share of challenges coming from the requirements area, maybe we're doing a brand new project, we don't really know what the users want, we don't know what the market wants, or maybe we've got a bunch of political stakeholders in our organization who can't agree on what the right answer is. That could say that the requirements are challenging and maybe the design and construction really aren't very challenging. That calls for a higher focus on requirements. In the second diagram in the middle on the top, that's suggestive of a project where most of the challenges come from design. And maybe we've got requirements that are very well defined, but the design challenges are very high. It requires a high degree of invention, maybe advancing the state of the art in some way. And maybe it's easy to state the requirement, provide perfect natural language translation from English to Chinese. Okay, that's an easy requirement to state. Implementing it requires a lot of work and a lot of invention. And you can kind of see how that would play out across the rest of the pictures. And it's certainly possible that challenges come from any of the areas or all of the areas. And so this gives us a useful way to think through where are the challenges likely to come from on this specific project, and gives us a way of thinking about, well, okay, then how would I change my approach to increasing activities or adding specializations in those challenge areas. So we've looked at 3 tools for understanding project scaling, and now let's go ahead and summarize. I think that with many Agile issues, the discussion treats the scaling issues as though the topic is Agile scaling, where their key consideration is that we're doing Agile. In practice, I think the challenges come more from the fact that the topic really is Agile scaling, where scaling is the difficulty, and Agile is actually contributing to the solution. It's making it easier if the Scrum implementation or other Agile practice implementation is done well. That's actually making it easier to scale than it used to be, not harder. And so understanding that the primary challenge here is scaling, I think is one of the main things that you need to understand. I think in general, large projects are difficult, not just Agile projects. The problems scale non-linearly, and so the solutions need to scale non-linearly too. I think that the tools that I presented are very helpful in understanding both scaling challenges and how we might approach solutions to scaling. That 4 factors life cycle model, in particular the size factor, gives us some very good insights into how we think about issues at scale. The Kokomo 2 model helps us to get an understanding on what kinds of problems emerge at scale that we don't really have to deal with on smaller projects. And that intellectual phases and activities model gives us an idea of how would we tailor our solution to the fact that different problems are emerging at scale. And this slide will be available after the presentation or after the conference, so you can look at it at your leisure, but it really just summarizes how the interactions of the 4 factors life cycle model, how human variation interacts with size, how uncertainty interacts with size, how defects interact with size, and then how the life cycle model overall interacts with size. And then also, just again for your reference, give some ideas of how the 4 factors model responds to the different challenge areas from the intellectual phases model, the phases of discovery, invention, and construction, and then goes through how we might respond, just some memory joggers or prompts about how we might respond to high challenge in discovery, high challenge in invention, high challenge in construction. There's a lot more detail on these topics. The Understanding Software Projects lecture series, we always have free lectures available in our Construx on-demand environment, and we'll follow up with some links that you can use for accessing those lectures as the days, weeks, and months go by. I also have a forthcoming book called More Effective Agile, which will be out in the late spring, and that contains some more discussion of some of these topics as well. And at this point, I'm going to go ahead and open the floor to questions. And I'll try to get my chat working here and see what kind of questions we might have. All right, let's see. Okay, so it looks like first question we've got is, it seems like one response to your talk would be to only do small projects. Have you ever seen any company take that approach? Did it work? Yeah, I have seen a company that took that approach. One in particular comes to mind. There was a software tools company that I worked with very briefly that had an approach of what the terminology was kind of popular at the time. This is quite a while ago, maybe 15 years ago. And the terminology was 3x3 project, 4x4. And what that meant was 3 people for 3 months, 4 people for 4 months. 3x6 would be 3 people for 6 months. And this particular company had defined its entire business model as whatever software tools it could develop that could be conducted in 6x6 or less. In other words, any project that could be done by 6 people in 6 months, they were willing to consider that or take that on. But anything that looked like it was going to be longer than 6x6, they decided they just didn't want to do. And in essence, they were saying, we'll only do projects that can be completed by a self-managed team. We're not going to do any projects that require higher level of management. So, I think that's a pretty interesting constraint. I think if you're a niche player, you could do that. But, one of the reasons that projects get larger is that they're successful. And if an earlier small version of something is successful, people want more of it. And just the nature of software is it becomes bigger over time. And so I think that can become a pretty severe self-imposed limitation where you're basically over time saying, yeah, people want more of our stuff and we're just not going to give it to them because we're going to stay small. So I think that's a very difficult, at a technical level, it's a great strategy, but at the business level, I think that becomes a very challenging strategy. All right, let's see what other questions we might have here. Let's see. Oops. Okay, next question. What is the reason that error rates go up so much on the largest projects and productivity goes down? Yeah, well, the second part of that's easy to answer. Why does productivity go down so much? Because error rates go up so much. That's actually a big part of it. The time we spend finding defects, fixing defects, making sure we fix the defect correctly, adding regression tests for those defects that we found, the higher number of defects, that actually adds a lot of work. So part of the answer to why productivity goes down is because the error rates are going up. The other part of the reason of why productivity goes down is there's just a lot more coordination. We've got coordination work where we're coordinating design level, architecture level stuff, and that's overhead on the project. We've got management level coordination where we're just coordinating handoffs between teams and people going on leave or vacation schedules or just status coordination that goes up. We've got process coordination, so that tends to go up, and we've got requirements coordination about part of it is who's responsible for what, allocating requirements, but part of it is also making sure the teams aren't tripping over each other as they do related work and requirements need to get reconciled across teams and stuff like that. So really, I think it's defects is a big factor, and just all that coordination overhead is a big factor as well. All right, looks like we've got time for at least a couple more questions. So let's see, human interface versus process interface, aka meeting versus tools. And does this work using pizza box sized teams? Yeah, the 2 pizza team is, I like that terminology. Basically refers to, if you haven't heard that terminology before, it refers to the idea that we have a team that can feed itself on 2 pizzas. And I think it becomes a proxy essentially for a team that's small enough to be a self-managed team. I think what we tend to see with teams that size, and we talk about human interface versus process, is that for self-managed teams or teams that size, we can actually be pretty successful with tacit work practices and tacit processes. We also use the phrase tribal knowledge. In a team that size, especially if there's low turnover and people work together for a long time, they just develop a shared understanding of how they're going to work together. If they're using well-defined practices like Scrum, then that adds to their shared understanding of how they're going to do work together. I think one of the things that changes as you get beyond that size, now I've got 2 teams, and that understanding, even if it started out as a tacit understanding, can diverge as the teams don't have the same level of interaction with each other over time that they have interacting with each other if they're all in one team. It just creates opportunities for miscommunication and process mismatches and inefficiencies and errors. And so, even that split from 1 team to 2 teams is a significant split. And so, yeah, and it requires, two teams is not an enormous challenge, but it's certainly more challenging than one. And it does require more explicit focus on at least minimally defined processes and interactions and so on. All right, so I think we got time for one more question. So yeah, this is a good question. I'm surprised to see the construction effort goes low in larger projects compared to smaller projects. So yeah, let me be clear about that dynamic. It's not that construction goes low on large projects. It's that it scales less exponentially than the other activities. So construction effort is going to scale non-linearly. So there's going to be disproportionately more construction on larger projects, but the other activities scale even more non-linearly. So architecture, requirements, system test scale up faster than construction does. So if that graph that I showed you was about percentage of activity allocated to, or rather percentage of overall effort allocated to those different activities over the course as project size increases. And so it's not that by any means that construction effort goes down, it goes up. It just goes down as a percentage of the overall effort. So that's a really good clarification. All right, well, I'd like to thank you for joining us for the More Effective Software Conference and for this talk this morning or afternoon or evening, depending on where you are. We've got a lot of great talks coming up for the rest of the conference, including one by me later in the day tomorrow. And so thanks for being here, and enjoy the rest of the conference.